Hello students, integration by substitution is what we are discussing. Let us see the first example in this module. It says integral of x sine inverse of x square upon root over 1 minus x raised to 4 dx. We have already analyzed this sum in the earlier modules. Students, the first step is copying the question. Now, what are we supposed to see here? We know that sine inverse of x square is a composite function and derivative of sine inverse x square is also there. So I can go to substitute sine inverse of x square is equal to t. Is that okay, students? Now what is derivative of sine inverse x? Derivative of sine inverse x is 1 upon root of 1 minus x square. So here when I apply the derivative, I'll get 1 upon root over 1 minus x square the whole square. Students, please remember it is composite. So the derivative does not end here. We need to differentiate x square to get 2x. So is equal to dt. Can I write here? Okay. Let me just rearrange this. So can we say 2x dx upon root of 1 minus x raised to 4 is equal to dt. Is that okay, students? Now if you see in the integral, I have x upon root of 1 minus x raised to 4. So this 2 is extra. I'll bring this 2 down to get dt by 2. So now students, how will my integral look like? So can I say the integral is sine inverse of x square into x upon root of 1 minus x raised to 4 dx. Now students, if you just recall, sine inverse of x square was t. So in the next step in the integral, I will write t in place of sine inverse of x square. Is that okay? What about x upon root of 1 minus x raised to 4 dx? X upon root of 1 minus x raised to 4 dx, my students, was written as dt by 2. So this was dt by 2. So can we write here dt by 2? So now see, the integral is such a simple function which is t dt by 2. So in the next step, I know half is a constant, so I'll take it outside. I'll have t dt. Now integral t dt is of the form x raised to n. So we'll have to apply the formula of x raised to n. So on applying the formula, we'll get 1 by 2 into t square by 2 plus c. T square by 2 and 1 by 2. So in the next step, can I say t square by 4 is what I'll get. And we'll write this as 1 by 4. Now can I write t? Not at all. So sine inverse x square the whole square plus c. And that's our final answer. Okay, let us take some more examples. Now these are examples based on the same sum. Some of them have been asked in the earlier board exams. They are on the same lines. Let us take the next example, students. Integral of e raised to x into 1 plus x upon sine square x e raised to x. Now, students, you know that x e raised to x is a function of x, which makes it as a composite in the denominator. We also observe that the derivative of it is present in the numerator. So now students, what am I supposed to do? I am supposed to substitute that x e raised to x as t that we have already seen. So if I copy the question, what is my next step? The next step is x e raised to x is equal to t. Now students, when I have to differentiate with respect to x, we know that the left hand side is a product of two standard functions. So we need to apply u into v rule of derivatives. That is, on differentiating, we'll get x e power x plus e power x into 1 is equal to dt by dx. Is that okay, students? Now if you observe, the two terms on the left hand side have a e power x common. Both the terms have a e power x. So we may rearrange as e raised to x or e power x into x plus 1 dx is equal to dt. Is that okay? So what will the integral look like? It's a very simple integral. Integral of 1 upon sine square t dt. 1 upon sine square, students, is cosec square. So can I write it as cosec square t dt? Yes, my students? Now, integral cosec square, a very simple formula, minus of cot t plus c. The last step is write that t as the function we substituted, that is x e raised to x. So can I say minus of cot of x e raised to x plus c, and that's our final answer. Now students, there were some more examples in this type which were asked in the board exam, and Here is a list of these examples. They are on the same lines. You may observe they are all in terms of x e raised to x or x square e raised to x. So substitution is also similar to the previous example. And that's all we have in this module. Thank you very much.